In this video I'm going to show you how to use multimeters, different types of multimeters I have in front of me. All of them mainly have the same basic principles. As far as measurements. I've got this little one, and then a little bit bigger. As you go bigger sizes, also they have bigger ranges of voltage and currents and ohmage and anything else that you want to measure. This one, as you can see, is an analog. The rest of them are digital. That's another digital. This one analog. This analog one, I've still kept it in the bag. There's a reason for that. I've had this since childhood, and when I was going to school I bought this, and my teacher saw this because everybody was buying one, and he just mocked me to keep it in the bag because he said it won't take a day or two before it's all ripped out and the whole thing is greasy and all sorts of things. And I thought, you know what, I'm gonna keep this on this bag for as long as I live. So I've kept it. That teacher probably is, I don't know where he is, he's probably dead by now. I don't know, it might be still around, but however, it's not a spite, it's just because, you know, he didn't know me, he didn't know how I keep things immaculately and look after my devices. I would have probably taken out of this bag and I would have, you know, used it like normal, but because of what he said, I specifically kept it in this bag anyway. But I did use it. As you can see, it's torn a little bit, the bag is torn and it's not the same as before, but I've kept it in its own box. It's Hioki. It's a Japanese made multimeter, analog multimeter. Now I show you the differences between these and those digital ones. I've still use it because sometimes I need this, you know, it's quite handy to use for certain things. And then I have this also digital multimeter. It's bigger and it's got a bigger range of voltages and currents and ohmage, and also got another pocket multimeter here. It's quite handy, quite useful. It's like a calculator. You just put it in your pocket. I haven't seen anything like this in any of my travels in the European countries or in America. I've bought this from South Korea. Again, it's one of those things that you just think, how advanced are those people? This is made in Japan, and I'd gone to South Korea in Seoul as part of a business, and I got this from there. It's very basic. It's got DC voltage, it's got off switch, DC voltage, AC voltage, ohmage, and diode test, which is basically continuity test, not the continuity that you know for installation, you know, electrical installation, because it won't give you that much current to test that, but it's just continuity as far as like testing wires and things like that. And it just tells you here the range of voltages you can measure and ohmages. So it's AC DC 500 volts maximum. So that's that one that I quite like, and I've treasured this, same as that one. I've treasured them and I've kept them in my special box. Now, so that one is quite easy to use, really. It just tells you what they are. You just select the switch, if you're not using it, you put it on off switch. If you're using it DC, if you're measuring DC voltage, you put it on DC. AC, if you're measuring AC voltage, if you're measuring ohms, on ohm, and if you're testing the continuity, like this for instance, it just gives you that beep to say your wire is okay, it's got the continuity going. So that's that one. That's very simple. The digital ones are simpler than analog ones. I know they don't tend to use analogs anymore, and most of you probably aren't aware of having such a thing, but the principle stays the same. All of them have a selector switch. Now this selector switch has its own ranges of different measurements. If I just show you on one of them, then you can see they're all more or less the same. So you have all this selector switches divided into parts. If I start from, let's say, here, from here, this thick line to this thick line is AC amps. So it's amp with this AC sign. That means you're measuring the current or amperage of a circuit. So that means you're measuring the current or amperes of a circuit which is operating AC. This one is DC, from here to here, from this line to this line, which says 20 microamps, 200 microamps, 2 milliamps, 20 milliamps, 200 milliamps, 2 amps, and 10 amps. So it goes from there to here, and then it goes from there 200 microamps, 2 milliamps, 20 milliamps, 200 milliamps. The same values, same number of divisions, maybe 2 amps and 10 amps. It doesn't have to be necessarily the same number of divisions. Each multimeter is different. Like for instance, this one, it's got that range. You see, it's got a cut. You've got these lines around the circle, and then they've got cuts. That means the range for amps, for instance, DC amp is finished here, and then it goes on to something else. HFE is for measuring the HFE, or the gain of a transistor. Most of the digital multimeters have that, and then if you have that symbol, which is like a sound, that is continuity test, or usually, because that one is small, it doesn't have actually, they didn't have room for it, they haven't put the diode there. Actually, they put the diode here, they can test that diode there, but here is continuity as well. So I don't know why they separated that. Usually it's the same place, like this one, diode and the continuity, and that sound, the beeping sound, is the same place. So back to this. So you have a range of AC current or amperes, and DC, that line, straight line with dots under it, and amps as the unit for current, the same amps as unit for the current, but this sine wave means AC, this line, a straight line and dots under it, means DC. Sometimes they actually say DC, sometimes they don't, they just put that symbols there. Usually they just put the symbols there. And then you have that diode shape with a note next to it, with a musical note next to it, or the sign of actual sound, the symbol of sounds, which looks like a Wi-Fi signal. That just tests the continuity. For instance, again, if I just show you that, just turn this on with that button, and with this I have the probes, and they have these plugs that actually cover the probes, and so I just connect that. That just shows me the continuity, and it just says 0. If you don't hear that noise, it doesn't matter. Sometimes that buzzer, that little speaker might just go off after a while. Using this for a long time, it might just not work anymore. But as long as this just gives you 0, that means you have the continuity. It doesn't have to be exactly absolute 0. If it's even 002 or whatever, something like that, that means it's almost 0 resistance or 0 ohm. And that is probably the resistance that what you see here is probably resistance of these probes. With the analog ones, you can zero that. With the digital ones, some of them you can calibrate and zero it, but some of them you can't. With this one, I have no control over it. And so it goes on to, after that, usually after the diode or continuity test, you have another range which starts in this case on this ohm meter or multimeter, starts from here 200. If it doesn't say anything, that means ohm, because that is the sign or symbol for ohm. The omega, that's the symbol for ohm, and that goes to 200 mega ohms. So if it says K in front of it, is 2K ohm or 2 kilo ohm, and it moves on to M, that's mega ohm. So up to there is measuring ohmage, so you can measure, for instance, the ohmage or the resistance of your resistor. Your body at the moment is testing is measuring the resistance of my body, and it's 2.5 mega ohm. And then it goes to HFE again. That is when you want to test the transistor, and you have the pins here for transistor. If you want to test the HFE, it tells you how to put the pins of the transistor to measure base collector and emitter of a transistor like this in this side of the socket, to measure if they are PNP, and if it's NPN, you put it this way, and it measures your HFE, and it just basically tests your transistor to be okay or not. Then after that, it goes on to from here it starts the voltage. Again, this symbol, straight line with dots under it, V, that's voltage, and that line dots means DC. And then here starts the ACV, AC, that's the symbol for AC again. So this side is, this range is DC voltage, this range is AC voltage. Now, when you're measuring any of these, common plug is the negative, or the black one is always plugged into COM or common, so that goes there. And the positive, depending on what you're measuring. If you're measuring usually like this one, voltage and ohm is here, you put that there. If you're measuring voltage, so you're on this side, either voltage AC or voltage DC, or ohmage, or even continuity or HFE, you just use those two. But if you're measuring current, you have to unplug this and connect it to either this one. In this case, usually you have one socket, but in this multimeter I have two. One of them is for amp, it says, so I can put that there. It measures up to amps. So if my selector switch is coming here, for instance, to 2 amps, then I'll put it there. I've moved on from milliamps to 2 amps. As far if it's you know, if you're measuring amps up to 10 amps, because usually if you have another socket here that says 10 amps like this, and you're moving to this one, you shouldn't have this here. So so if you're measuring voltage or ohmage, then you have your positive here. You don't ever move that negative. Negative is always there in the same place, common. But positive, or the red plug, is here if you're measuring ohm or voltage or HFE or continuity. But if you're measuring amps, whether it's current, AC or DC, then you have to move this, unplug it from there and put it here, which says amp. It says A, amps. And if you notice, there's another one here on this multimeter. Usually you have one, like this one. You only have one, and that says amps. In this case, you don't even have that. You don't have an extra plug. You only have one set of plugs coming out, and it's fixed. And the same as this one. So you only have. You don't actually have amps. You just have voltage, AC, DC, ohmage. So some of them have amperage. Some of these multimeters have amperage socket. Some of them don't. But if they do, you have to actually unplug this and connect it to that special amperage. And usually it says, you see in this one, it says 10 amp DC. So if it's not more than 10 amps or less than, if it's 10 amps less, you just keep it in the same place. Usually it just measures all that voltage and amps. But if it's more than 10 amps, it's fused 10 amps, it says, you put it in this socket. With this one, whether it is 10 or not, or less, you have to actually put for amperage. You can't keep it here and measure amperage. You have to put it here or here. The only decision factor is if you're measuring the amp, you have to just have a good guess whether your amperage is going to be more than, your current is going to be more than 10 amps or less. If it's less, you just keep it here. If it's more, here. If you're not sure, I would start with the bigger one, then go down to less. If you can see how much your current is. If it's showing like 2 amps or 0.00 something amps, then you move it to this one. And the same with your range. You start with the biggest amperage or biggest voltage. If you don't know, if you're not sure what kind of voltage you have or what kind of current you're dealing with, then you just put it on the maximum you can measure. And from there, if you're measuring 0.00 or smaller values, then you keep going down on the selector, and if it's current, you go down to this one, and if it's voltage or ohmage, you just keep it on that. The same with the ohm. If you can start from the big and go down, but ohmage, if you're measuring the resistance, it doesn't really affect the multimeter if it is big. If you're measuring the resistance of your body or a resistor or something, if it's big or small, it doesn't make much. Well, it makes a difference on your reading and how accurate it is. The closer you get to the range, let's say if you're measuring a 200 ohm resistor, let's say you're measuring a 100 ohm resistor, and you put it on 2K or 200K, your accuracy is less than when you're measuring it on actual 200 ohm maximum rate. On 200 maximum rate, your accuracy is more accurate. It gives you all the decimals as well. With the voltage, if I don't know what the voltage of that socket is, if I'm in a strange place and don't know what the voltage is, I start with the maximum 1000 volt DC, for instance, 700 volts, or sorry, DC 1000 volt, or AC 700. I have maximum AC 700 volts measuring here, and that's my maximum rate. So I'll measure with that. If it's showing smaller values like 100 volts or 200, then I can go down. But the next one here on my multimeter is 200. So if it's 250, I can't go on that because it'll damage my multimeter. So you're just choosing basically as you measure. You're choosing your selector to get the most accurate measurement as you select. For voltage and whether it is AC or DC, for voltage you just basically connect the plugs either side of your pins or socket or plugs or whatever it is you're measuring in parallel connection. The same with resistors and continuity and HFE and all that. But when it comes to AC or DC current measurement, you have to actually cut the circuit. These two plugs have to be connected in series with the circuit. So you can't just connect it either side of the, for instance, battery and say how much current you have. It'll just blow your, it'll damage your multimeter. If you have a fused multimeter, the fuse might blow, or it might pass the fuse and damage the internal components. So that's as far as how to use these digital multimeters. They're all the same principle, they all have the same principle. It's just, like I said, different ranges. One has a bigger range, one has up to 10 amps, for instance, to measure current, and the other one doesn't have more than a few amps, for instance. And this one, amperage, is only from 2000 microamps going up to 200 milliamps. So it doesn't even go further than that. 200 milliamps, it doesn't even get to 1 amp. And keep it on off if you're not using it. And if you're not using it for a long time, any devices that you have operating on a battery, if you're not using it for a long time, long periods of time, for instance, I'm talking about months, if you're not using for months or years, take the battery out and store it somewhere if you're storing it, because the battery will just rot there and destroy the compartment. With the analog ones, the same principle applies. You have, it's more colorful, in this case Hioki or Hioki, however you want to pronounce it. This one is model 3004 with capacitance meter, so it actually measures the capacitor, and also HFE. It was a new thing at the time, had to measure the HFE of a transistor. Not many analog meters did that. HFE is here, sorry, and this is my capacitor, microfarad. It measures in microfarad, 2 ranges. And then the rest is almost the same, identical. You have a range of resistors to measure, you have a range of DC milliamps, DC voltage and AC voltage, and that's it really. You have a button here to zero or calibrate, and also an adjustment if you're, for instance, going to measure an ohmage. I've set it on 1 kilo ohm, for instance, and if I just connect the wires together, you can see the needle has gone past 0, so you can just turn this and back. You see I can go back and forth, if you can see that, and 0 it there. There is, on the display, there's different scales for different things. For instance, you have a scale that goes from this end, it starts from 0 all the way back to whatever values you're measuring, and that is for resistors. And the same also, you have a black scale going on top of it, 0 going up to 2, which is the microfarad for capacitors, 2 microfarad. And the rest are going normal from 0 to whatever it is, let's say 6, 12, 30, it's all different ranges, and it says what they are, which one is for what. The one is, for instance, 6, 12, 30 is for AC and DC voltages, and you have on AC and DC ranges, you have 6, 30, 120, 300, and also DC you have 3, 12, 30, 120, 300 volts. Whatever you measure here, if you've set this, for instance, on 30 volts, and this needle goes to 20, your maximum voltage is 30 volts, and you've set it on 30 volts maximum, then it's 20 volts. But if it's, for instance, if you measure it on 300, so whatever you measure here, you have to times it by 10. So 30 is 300, basically. 20, if you measure 20, it's not 20 volts, it's 200 volts. Similar to digital meters, when it goes to kilovolts, or we don't normally have kilovolts, but if it's like kilo ohm or mega ohm, then you times it by 1,000 or million. Similar to that. Again, you have a special plug here. If you're measuring, for instance, special socket here for capacitors, you plug that in that. Sorry, this one is an output. It says output if you want to send a signal. It's like it acts like a little small signal generator. So this is why I said this differs to those. You can never use these digital meters to send a signal. But with these, even if you don't have that output plug, just one of these pins or probes can act as a signal. If you're, for instance, trying to find to find out if, for instance, a radio or an amplifier where the problem is, you keep giving a signal from the output, from the input to the output, to see if you get any signal. If you don't, then there is a problem there. You keep going back to the beginning, to the tuner. If your voltage is high voltage, like more than 1200 volts, there is a special probe here, and it's got that symbol for a high voltage. You can put that there and measure that. And this plug is for HFE. So you have to look at plugs and see which one's which. But normally, when you're measuring just normal voltages, normal current, amperage, and normal ohmage, just negative stays in common and positive in the positive socket. This screw here is to adjust the zero. If the zero at the moment stays right bang on zero, the needle is on zero. If it gets out of that, then you can adjust this with this. It's just basically to calibrate it. This is the calibration screw. And this switch is center zero. If I put this on this mode, and at that point you can actually adjust this to have the needle in the middle, and that is good for measuring voltages if you don't know which one is positive, which one is negative, but you know it's DC, so it goes either this way or that way. So that is another option for some of these analog multimeters, but not all of them. And also you have another switch here, HFE DC and DC AC ohmage. If I'm using DC AC ohmage, which is in this plug, if I'm using DC only amp, although I changed this selected to that, but I have to change this to this as well. Not all the ohm meters or multimeters have this switch. This is just a special one. Okay, so basically you see the differences between all of them. And there isn't any switch off position for this one because it doesn't have a constant reading here like this one. Even if you put it on any selector, selecting the resistors, still shows you 1 there, even if the plugs are not connected to anything. So you need to basically turn it off. And with this one you have a stand as well, so you can actually stand it like this to measure things, to look at things, and two different variations of it. So you can have it almost flat like this, or up a little bit like this, or completely flat. And also this one has this protective rubber casing which comes off, so you can change the batteries there if you want, and it protects if it falls or anything, it doesn't break. So I like this one. This is my favorite one, and this is my treasured ohm meter, multimeter, the same as that one, but I don't tend to use these quite often. It used to even come with the internal diagram of the multimeter. So that's that one. You know all about multimeters now, how to use them. I have a few links of multimeters to, for you to buy if you want to buy any of these types of similar to these multimeters. One thing I forgot to say, for instance, using these analog meters, for instance, just to show you the difference, if I just put that on ohmage or resistor range, and I have a capacitor here. Let's say I don't have a capacitor option here. Actually on this occasion, actually I have two ranges of capacitors measurement. It actually says on it with capacitance meter. It was a special thing. Not all analog meters had them. I want to show you what a difference is between this and that digital one. For instance, if I want to measure capacitor, this is a capacitor, not to measure it, just to test to see if actually this capacitor is working. So what you do, you just connect, this is a small 100 microfarad capacitor. So if I just connect the two plugs in on two pins of the capacitor, you can see I have to put it on a smaller range. You can see the needle just barely moving. And then what I'll do, just turn the plugs or probes around and connect it again. You can see the needle going up and coming down. And then if I turn again, same thing happens, the needle goes up and down. What's happening? The battery inside this meter is charging the capacitor and it's discharging it. It's charging it, and the capacitor, after it's charged, because it's DC, it stays charged, and because DC current doesn't pass through the capacitor, it works like an open circuit. So it doesn't really discharge. It just it discharges when you put it the other way. When you connect the plugs the other way, it's trying to charge it the other way, discharge and charge it the other way, charge the plates, and so it goes up. And when it gets to the maximum, then the current goes down to zero. So there's no flow of electricity, and that's why. So that's how you can tell this capacitor is okay. It's working fine. With the digital meters, you can do the same thing. And if you have a good digital meter like this one, and let's say set it on resistors like that, and you can see digital meters are just like that. They're jumpy a little bit, they jump up and down anyway. And if I'm doing this with capacitor, you can hardly see anything. And if I move that even further up, yeah, it just goes up and down very fast, and you don't know if it was your fingers, if it was just probes touching each other, because they're very, you see, it didn't move at all, and with this one, it didn't move at all. So if I go down to minimum 200, it doesn't move, and I go to maximum 200 mega ohm, which gives you more current, right? So you can see it goes up and down, jumping numbers up and down, and it comes to 0. See, 14, 20, 24, 16, 20, 24 again, 28, 30, 40, 59, 68. It's still going up, so it's trying to charge. 170, 200, it's gone to 1000, 700, and then back to 0. See what I mean? You can't be sure whether this is a good capacitor, is working or not, because those numbers are just jumping anyway. But with this, you can see charging, fully charged. Then when it's fully charged, as it charges, it goes up, because you have a flow of current going through the circuit, and that is the current going through it. And then although it's on resistor, checking, the selector is selecting a resistor, but the battery is giving this a voltage, and that is basically going through the capacitor until it's fully charged, and as it's getting charged, then this dial goes down to 0. To begin with, you have an initial current, and then it stops. It's that 5 times constant that it takes for the capacitor to charge, and then you change the polarity, and it goes the other way. So you can see some of the features you have on that you can never have on these. Anyway, that's my argument for that one. I want to show you this one as well. This is a volt tester probe. It's all plastic covered, insulated, so you don't need to, it's not dangerous if you put it in a plug or anything, in a socket. As soon as you turn it on, it keeps flashing like that every now and then, just means it's on. But when you get this near a live wire, it goes solid red and beeps solid. If I just show you that, for instance, I just get near a socket. If I just turn this off, see, it doesn't show that. But when I get near the socket anyway, this one. And it's good for checking the walls as well. Sometimes if it's not that, it's not a tester for that kind of thing, to test the wires inside the walls, but unless the wires are really to the surface, near the surface, then it can test that. But you can check the lives if the socket is live or not. You can even determine which one is live, which one is neutral. So it is very handy to have as an electrical engineer. You really need one of these. Well, I hope you enjoyed all that, and I have all the links that you will need at the bottom of the description. for your information. Thank you very much. See you again. Bye-bye.